Welcome to Geometry A Final Exam Review, pages 1 through 6, questions 1 through 14. Question number 1. Write the three undefined terms in geometry. The first undefined term is a point. A point is a position in space with no shape or size. The second undefined term is a line. A line contains at least 2 points, goes forever in opposite directions, it's straight, and has no thickness. The third undefined term is a plane. A plane has at least 3 non-collinear points. It goes forever in all directions. It's flat and has no thickness. Question 2. Construct the angle bisector of angle A below. An angle bisector is a line or ray that cuts an angle into 2 congruent parts. So when it says the word construct, we need to use a compass and a straight edge, no protractor. In order to cut this angle into 2 congruent parts, we need to put the sharp point of the compass onto the vertex A and open the compass to any setting that you want, and we need to make an arc that intersects the rays. Once we have that, we need to put the sharp point on this intersection and make another set of arcs. And our arcs should intersect to create a point, and we'll draw a ray from the vertex through that intersection. Question number 3. It says, construct a 45-degree angle using point B as the vertex of the angle. Now, we can't construct a 45-degree angle just as is with the compass. We need to first construct a 90-degree angle. So in order to construct a 90-degree angle, we need to construct a perpendicular bisector. So what we need to do is to extend this segment to the left of B. Now what I'm going to do is I'm going to put my sharp point on B, and I'm going to create a segment about B where B is in the middle. Now, what we need to do now is we're going to cut this segment into half at a right angle, so the perpendicular bisector. So I'm going to put the sharp point on one endpoint, open it up more than halfway, and make an arc. And then go to the other endpoint and make another arc. What I just did was create a perpendicular bisector through B. Now I have a right angle, and now what I need to do is cut this right angle into 2 congruent parts by doing an angle bisector like I did in number 2. So I'm going to put my sharp point on the vertex, and I'm going to make an arc, and then put my sharp point on those intersections and make another set of arcs. And my arc should intersect, and draw a ray through from the vertex through my intersection. And finally, label my 45-degree angle. I'll label it A, B, C, and I'll even put a 45 degrees here. Number 4. we need to construct a line that is parallel to the given line and also goes through point H. So the first step, in order to have parallel lines, we need to have a transversal. So a transversal is just a line that intersects two parallel lines. So what I'm going to do is just draw a line through the given line and through H. Why I did that was because I created an angle. And what I want to do is to copy this angle to the other side of H, which is the corresponding angle. Because it says that if the corresponding angles are congruent, then the two lines are parallel. So what I'm going to do is I'm going to draw an arc, and then go to H, draw the same arc, just make sure you don't move your compass like I just did. So I'm going to draw an arc, and then what I'm going to do is I'm going to measure this arc. And then I'm going to put it on the transversal and measure this arc. And the two arcs should intersect. Now, if the corresponding angles are congruent, then my line should be parallel. Number 5. It says the perpendicular bisector of AB is constructed. What is true about every point on the perpendicular bisector? So, in number 3, I believe, we constructed a perpendicular bisector. But I'm just going to draw a segment AB. And I'm going to construct a perpendicular bisector as a visual. So I'm going to put the sharp point on one of the endpoints. I'm going to open it up more than halfway. And then I'm going to draw my arcs. And I'm going to go to the other endpoint and draw the same arc. And what I just did was constructed a perpendicular bisector of segment AB. Okay, so now what can we say about every point on a perpendicular bisector? So I could pick any random point on a perpendicular bisector, and what's true about it is from any given point it's going to be the same distance to B as to A. So what's true about it is it's the same distance to each of the endpoints from any given point. So the angle bisector of CDE is constructed. So I can construct an angle bisector. So I'll draw angle CDE. So D is the vertex, so I'll put that in the middle. And what I'm going to do is I'm going to put the sharp point on the vertex, and I'm going to cut this angle in half like I did in number 3 and in number 2. So I'm going to make an arc. I'm going to put the sharp point over here and make an arc again. And up here. And I'm going to connect the vertex with that intersection. Now, what can I say about each point on, so this would be C, D, E. What can I say about each point on the perpendicular bisector, which should be equal here? There we go. So what can we say about each point is it's going to be equidistant to each of the rays. No matter what point I pick, it's going to be equidistant to each of the rays. It says a line is constructed parallel to a given line, which we did in question number 4. What is true about the lines? The lines will never intersect. So, number 8. It says point A, -1, -4, is to be transformed to point A prime. Using the translation rule, xy is transformed to x minus 3, y plus 6. What are the coordinates of point A prime? So I have a rule, x minus 3, comma, y plus 6. In my ordered pair for A, I have an x value and a y value. So now my x in my rule is now going to be -1. So I'm going to have -1 minus 3, and my y value is -4. So it's going to be -4 plus 6. So -1 minus 3 is -4. -4 plus 6 is 2. So my transformed point is -4, comma 2. Number 9. Triangle ABC has been transformed to triangle A prime, B prime, C prime. Now, it says, state in words the transformation that produced triangle A prime, B prime, C prime. So you're trying to tell me, in words, how did we move triangle ABC to its place where it's A prime, B prime, C prime? So it looks like it's a translation. So a translation is when it goes right, left, up, or down. So to go from A to A prime, it looks like I went 1, 2, 3, 4, 5 to the right, and 3 down. So 5, it was translated 5 right, 3 down. And you can check to see if C and C prime were exactly the same. So in a translation, they all have to do the same translation. So it would be 5 right, so 1, 2, 3, 4, 5, and then 3 down. 1, 2, 3. C prime's okay. And then what about B prime? 1, 2, 3, 4, 5. 1, 2, 3. Now it says write a rule that represents this transformation. So I start with x comma y, and that's going to be transformed to, I want 5 right, so it'd be x plus 5. And then 3 down, it'd be y minus 3. Now, why must triangle ABC be congruent to A prime, B prime, C prime? Is because a translation is a rigid transformation, which means it doesn't change the shape or size of the figure when it's been moved. Now, it says on the coordinate plane above, sketch the triangle, the reflection of triangle ABC across the x-axis. So a good strategy is I'm going to highlight the x-axis. So I transform it or reflect it across the correct axis. So I'm going to go across or reflect across A across the x-axis. So I'm going to go down 1, 2, 3, 4 to the x-axis. So I have to go 4 more down. 1, 2, 3, 4. And I'm going to call that D. And then B sits on the x-axis, so it's not going to move, and I'm going to call that E. And then C, it takes 2 steps to get to the x-axis, so I have to do 2 more steps down for point F. So this is also a rigid transformation because a reflection does not change the shape or size of the figure. So now it also says write the function rule for the transformation. So transformation would be x comma y, that's the original triangle, is transformed. How I remember it is if you reflect across the x, you change the y. So which means it's going to be if the y is positive, it now becomes negative. So it'll be y, x comma negative y. It says, let -3 be a point on the coordinate plane as shown below. It says, write the coordinates of the image point of -3, 5, undergoes the following transformations. So the graph is just for a visual. So if you need the visual to graph the points and then write the order pairs, then please use it. It says, I want to reflect -3, 5 across the x-axis. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my ordered pair is going to be -3, -5. So remember, if you reflect across the x, change the y. So the y was +5, now it's -5. -3, comma, -5. Now it says, now it's not a building process. We're not going to use -3, -5 to get my next point. We're going to go back to -3, 5 and reflect that across the y-axis. So it's 1, 2, 3, 1, 2, 3. So this ordered pair is 3, comma, 5. And when we reflect across the y, you change the x. The x was -3, now it's +3. So the ordered pair is 3, comma, 5. Now, it says translated 7 units to the right and then 2 down. So I'm going to go 7 right. 1, 2, 3, 4, 5, 6, 7. And then 2 down. 1, 2. So this ordered pair is 1, 2, 3, 4, 4, comma, 1, 2, 3. Another way you could have done it is add 7 to -3 would be 4, and then subtract 2 because I went down from the 5. 5 minus 2 is 3. So the ordered pair is 4, comma, 3. Now, it says rotated 90 degrees clockwise about the origin. So to rotate a point about the origin clockwise, I have this little strategy that I was taught. Is the first step is to flip the ordered pair. So it'd be 5, comma, -3. And it says clockwise. So what I'm going to do is I'm going to draw an arrow clockwise above the ordered pair. And wherever the head of the arrow is, I'm going to change that part of the ordered pair. So if it's -3, I'm going to change it to +3. So the ordered pair would be 5, comma, 3. Now it says rotate 180 degrees. All we have to do is change the signs of the ordered pair. So -3 becomes 3. 5 becomes -5. So if you want to graph it, it would be 3 and then down 5. 3, -5. And the last one, rotated counterclockwise 90 degrees about the origin. So my ordered pair was -3, 5. What I'm going to do is I'm going to flip the ordered pair, and then I'm going to draw an arrow counterclockwise. And wherever the head of the arrow is, it's over 5, so I'm going to change that part of the ordered pair. So it was +5, so now it's going to be -5. So the ordered pair is -5, -3. 1, 2, 3, 4, 5, and down 3. Question number 11. It says, reflect the figure above across the line y equals 1. So I'm going to highlight y equals 1. So y equals 1 is a horizontal line through y equals 1. and I'm going to reflect it. So it just works the same way as the x-axis. So it's 1 step, 2 steps to the y equals 1 line. So I'm going to go 1, 2. So that's going to be A prime. 1, 2. So I need another 2. To get to C, to the line, it's 1, 2, 3, 4. 1, 2, 3, 4. And then D would be 1, 2, 3, 4. 1, 2, 3, 4. So connect the dots, and this is my trapezoid that's been reflected about the y equals 1 line. Now it says, does this transformation preserve the length and angle measurements? Justify your answer. Yes, because a reflection is a rigid transformation. Anytime I reflect, it preserves the shape and size of the figure. If the figure was reflected across the x-axis, so I'm going to go across the x-axis this time, and then 2 units up, do I get the same results? So let's check A out. So I go 1 to x-axis, so I go 1 more, and then up 2, 1, 2. I land on A prime. Let's be certain, how about B? So I go 1 to the x-axis, so I go up 1, and then up 2. B prime's fine. If you do C, 1, 2, 3, 1, 2, 3, and an additional 2 up, 1, 2. I'm hitting every point where I'm supposed to. So 1, 2, 3, 4, 1, 2, 3, 4. So do I get the same answer? Yes, because every time I did it, I landed on the answer I got for part A. Question number 12. Write the 3 rigid transformations. The first thing we learned was that a translation, right, left, up, down, is a rigid transformation. The second one we learned was a reflection. I could reflect about the x-axis, the y-axis, the y equals x line, the x equals 1 line, the y equals 1 line. It's going to preserve the shape and size, integrity of the shape. And then the last one is the rotation. The 90 degrees clockwise, counterclockwise, 180 degrees will preserve the shape and size of that figure also. So if a figure undergoes a rigid transformation, then the transformed figure must be congruent to the given figure, or to the original figure. And our final question. Look at the figure below. It says complete each statement such that each transformation will map the, not triangle, it's a typo, the figure onto itself. So which means, can I able to fold it up and down or right and left to produce so it goes on top of each other? So I can reflect across the x-axis. So what if I reflect across the x-axis? I'll highlight the x-axis. If I fold this down, it will land right on top of it. If I fold this thing down, folds right on top of it. The little triangles fold right on top of it. So I can go across the x-axis, or that folds it up and down, but what if I want to fold it right and left? I could fold it across the x equals 2 line. Now, I also have a point of rotation right here at 2, 0, as long as I rotate this 180 degrees. I hope this portion of the video has been helpful for you, and good luck on the final exam. Study hard.